The broadcast is now starting. All attendees are in listen-only mode.
Hello, everybody. My name is Randy Robb, and I'm a principal consultant here at Oxford Computer Group. And today's webinar is going to go over Azure AD's modern authentication protocols, and we're going to look at that at a pretty deep level, try to show everybody what's involved with that from a fairly technical perspective. We're not going to go super deep like into coding, but at least we'll show you, I'll show you how it works so you have a good idea of what's going on there. I can get my slides to work. OCG, this is a slide that we're supposed to give you guys so that you know what we do. I think most of you probably know who OCG is. We do planning and assessment projects. We have deployment services, and we also have managed services. We have a lot of people on our team that are really into Azure AD and identity management, application security, Azure security. So there's a lot of things that we do. My role as a principal consultant is to help with identity projects, as well as help companies integrate with B2C and other types of Azure applications. I do have an application development background as well as an operations background, so I know all that stuff pretty well. If you guys have any questions at all as we get into this, is there audio? Yes. Do you not hear my audio? Jackie, are you there? Do we have audio? Oh, okay, good.
Yeah, you're good, Randy.
Okay, because we had a question. Thank you. Anyway, as you can see that some of you posted in the questions area. If you have any questions, I can answer those at the end. So what are we going to talk about today? Well, when I started working with Azure and modern authentications and those types of things, I really struggled with what was happening here. I would log into Azure and I would see something like this where I go to portal.office.com and there's a sign-in screen there. And there are a couple of links down at the bottom that you can see there. The no account, create one, but you have sign-in options at the bottom. If you click on that, you can see that at least in this example, you've got a couple of things there that you can sign in with. In some situations you see more, in some situations you see less. And if you look down below, it says there, create an account, and then you have an account creation screen, and if you need help, then this other screen comes up where you can ask for help. And in other situations, when you try to log in, you pick an account, you have all these accounts there. And so that really confused me because I really wanted to, I did have an application background and I knew about modern authentication, but I wasn't really sure what was happening there. I wasn't really sure how all the pieces fit together. And so the main point of this webinar is to actually show how OpenID Connect and OAuth 2, which are modern protocols, how they interface with Azure and how those things happen that you see there. The other things we're going to, if we look at this, it'll really help you to identify security solutions as well. How do you secure an environment? What's really happening there? So hopefully I'll answer some of those questions. So modern authentication. We all know that Azure AD utilizes modern authentication protocols for security, and those are OAuth 2 and OpenID Connect, and it also integrates with SAML, which I don't quite consider a modern authentication protocol, but it is a federated identity protocol. And the real key is to see how this interfaces with Azure. When I started out learning about modern authentication and how it works, So you can get on training sites on the internet to really understand how this stuff, and they typically find out, or they typically show that there are 4 actors involved. There's a resource owner, there's an authorization server, there's a resource server, and a client. That's typically how they present this. And I struggled with knowing, well, what's the resource owner? Well, a company owns the resources. I'm not the resource owner, the company owns it. And what is the resource server? Is that their website that houses the application? Is it the website that houses the data? What is it? And client is pretty straightforward. That's what you're trying to access the information with. So it was really all kind of confusing to me. And if you look on the internet, this actually came from a slide that I found by Okta. But then it shows kind of a diagram here where you have a resource owner and a client and arrows pointing back and forth, but it doesn't really help me understand what's happening within Azure, because I have these screens pop up and I know that there are refresh tokens, and how are those even utilized within Azure? And then you go to Microsoft's website and you see something like this that's maybe a little bit more straightforward, but at least we have arrows going to a web server, and we have the middle thing there that's called the authorize, and you have this other thing on top that says it's a Microsoft identity platform, and things seem to point to that middle thing right there, but it still doesn't really clarify things for me. So even though all these are correct, I struggled with trying to understand this. So not only that, but there are more and more things that Azure is adding, like support for external identities with your Azure client, that make it really important to understand how all these things fit together. So after a lot of research and a lot of trial and error and understanding fiddler traces and things like that, I'm going to show you how things really work within Azure. And part of this is to understand how initially how modern authentication works at an overall level. And I start with this by saying that what we're trying to present is protection of resources. And companies have resources, they own resources, and they want to protect those. And that can be like a database, file server, email server, whatever. It's data that they want to protect. And the data is protected via applications. And these applications can be a website, it can be a workstation, it can be a server, it's anything that has access to that those resources. And the application is really what provides security. Applications provide authorization, and in most cases, especially with the legacy environments, they include authentication as well. So this is really the model that that we're trying to protect with a modern authentication protocol. Modern protocols are OAuth 2 and OpenID Connect, which I said before. And the first step in understanding those two is that OpenID Connect is really just OAuth 2. And OAuth 2 provides an access token to secure application access. And OpenID Connect is just OAuth 2 with an additional scope and an additional token that's available, an ID token. And an ID token specifically talks about the user and that has access to whatever you're trying to get to. I'm going to go into this a little bit more detail. So we've simplified the process by really showing that modern authentication is used by the application to control access to the data. And so we've said that this data is protected by the application via the OpenID Connect or OAuth 2. And one of the keys to understanding how this whole thing integrates with Azure is the Authorization Server. And everything else that you've seen about OpenID Connect or OAuth, you can kind of put in the back of your mind and focus on the authorization server, because that's really the most important part of this whole scheme of how everything works together. The authorization server is what mediates the request between the application and the underlying security system. And the authorization server acts as a mediator between the system that's providing the security and the application. And this is really important to understand because it doesn't secure anything. The authorization server never secures. It's responsible and there to make sure there is security, but it doesn't provide security. It doesn't provide authentication. It can pass that authentication or that security to another process. So if it doesn't provide, if the authorization server doesn't provide security, how are applications secured by this? Well, the authorization server brings back tokens. When you have an application, you usually have something that is trying to access the application, like the user, and it's the application's responsibility to determine whether it can talk to the backend data store to see if it can give that data to the application and eventually to you. So it integrates with the authorization server, and the authorization server then performs what I call an authorization event. It does something on the back end so that it can give you a token. And if tokens are returned, then the application can say, oh, this token, which is just a set of attributes and name value pairs, basically, that the application can say, oh, this is this user, or this is this user's from this department, or this application has this token, I can give access to it. Well, the important thing to know is that the authorization event can be anything, and only if that's successful will you get a token. And looking at how this happens within Azure, the authorization event can be a user logon. The authorization event can be a refresh token. It can be a device token. It can be the confirmation of an ID and secret. It can be anything that you want it to be, as long as it interfaces with your authorization server. And it's this authorization server interface that redirects user to your AD logon screen. It provides verification of the refresh token, and it is the server there that that utilizes B2C custom profiles. The authorization server actually utilizes those profiles for the user journey, and if that's successful or not, then it can bring back tokens. Here's an example of, if you go to portal.office.com, this is an example of an authorization server endpoint. And the process of understanding how all this works together is that the company resources, your data needs security. The resources are protected by applications. The applications need security. And the security is provided by a modern authentication service provider, which gives you your OAuth 2 and OpenID Connect interface. An application then will go to the authorization service, the authorization server that's part of the service provider. And as long as there's a trust there with that application, then the authorization server initiates some type of authorization event. It can be based on its data that it has. It can be based on, like with B2C, the user journey, the custom profiles that you've created. And when those are successful, tokens are then returned based on the data that it gets. And then the application can then look at those tokens and allow resource access. Here's a diagram of that process, a little block diagram that shows Azure there and an application that's registered in Azure. You can see here that the user is trying to access this application. The application then sends its request to the authorization server, which is then does an authorization event, whatever it needs to do. If you don't have a token in your browser, then it's going to prompt you for a login. If it does have a token in your browser, then the authorization event will grab that, verify it, and bring back the correct tokens for the application if that refresh token hasn't expired. And then depending on what the application determines with the tokens that come back, it will either give you access or not. The application is a level of authorization. And here's another, a little bit more detailed diagram of how this works. Something wants to gain access to an application. The application needs access, needs to authorize that access. So it talks to the OpenID Connect endpoint of the authorization server. And with it, it sends the client ID, scopes, the reply URI, and other information that it wants to send to it, whatever the authorization server can accept. And the authorization server has several endpoints. You have an authorization endpoint, you have a token endpoint. Tokens can come from either one of those two endpoints depending on what you are trying to get, whether you have implicit flow or not. There's a configuration endpoint. And so once you go here to your authorization server endpoint, it checks to see if the application is trusted. If you've registered that application, it's sending the application ID over to it. And then once it's trusted, it then fires off some type of authorization event. It can be a login. Like I said, it can be anything you want it to be, anything that the authorization server is configured to do. And once that's successful, if that is successful, then it will send the tokens back to the application, or actually to the reply URI, which is usually the application. And it's up to that receiving end to verify the tokens that it came from the authorization server. You do that via hash. And then these two are where the trust comes in place. And then the application then can give you appropriate access based on your token. And once the authorization server succeeds, like I said, a token or tokens will be delivered back to the application. And the application should verify these. If you don't have a library that does it for you, you should actually verify those. And how a system like this integrates with an external identity provider? Well, what it does is you go to, like in this scenario, we're trusting an external IDP. This is basically the same diagram as I showed you before, where the user wants to access an application. It goes to the authorization server. It needs an authorization event. Well, you configure the environment so that if you trust another IDP, then that authorization event goes to another IDP that is actually another authorization server. So the same process happens. There has to be an authorization event of some kind on this other system. And then tokens are brought back if that's successful. And the authorization event then determines if that's a good token or not, if that's allowed. And if it is, then it gives back its own tokens back to the application via the authorization server here. And the key takeaways of this is the applications determine the authorization via token analysis. So this is modern auth integration. Your applications actually get the tokens, and based on the information in the tokens, whether the token is expired or different attributes within that token, it tells you what access you have to the application. And the applications can only receive those tokens if there's a successful authorization event. So within an Azure AD tenant, that controls the authorization events by additional security mechanisms. And that is authentication, right? That's part of it, but it's not limited to authentication. The Azure AD tenant itself has all kinds of things built around that authorization event, like conditional access policies, MFA, high risk account analysis, and whatever other controls. So there's so much more within that that you get rather than just standard OAuth 2 protocols. So this is kind of a block diagram that shows that your application, if you build it with Azure, it does have the standard authorization capabilities that you get from those protocols. But when you integrate it with an Azure AD tenant, because that authorization server offloads a lot of the stuff, you actually have a lot better fine-grained control over everything by these additional controls that you have within Azure. So it basically extends your protocols there that you can use. It extends it to add all these other policies and features. And what I want to talk about is federation. Now, if you take a look at this diagram here, the source of authority for everything is the Azure AD tenant, but you can federate with another environment if you want to. That's a capability that Azure AD has within it. So you can federate like with ADFS or with Ping Federate or Okta or something, some other third party. And what I want to show here is it doesn't move any additional authorization processes out of the Azure AD tenant. All it does is just, like in the example where you offload an authorization event to another IDP, you're just federating those processes to another environment, adding things to it, not securing anything that is in that source environment. And the Azure AD tenant can't be totally managed by a federated provider. Here's a diagram of that you have on the left here. We have your Azure AD tenant or the application rather, that is using the standard OpenID Connect protocols there, OAuth 2 protocols. And then you have your controls in Azure over here that I've talked about. But you've decided to federate that with something else, with another, maybe with ADFS on premises or with another provider. And so you're offloading these things. And you have a different additional authorization controls here. So these things are additive, but they're not exclusatory to these things that are up in the middle here. And this is, like I said, these are additive. And only if you have an account on both sides can you secure it, because the security frame is around Azure AD. That is really, the admin there is in control over everything there, and those accounts that are not attached to this federated provider, they have they can have additional authorization processes. And here's an example where you have a rogue AD admin may be able to create a user, assign them an Office 365 license, and utilize email. And if you want to control that, you can only control that through policies within your Azure AD tenant. You can't control that via any type of federation. And here's an example of that. Here we have an Azure AD tenant that you federated with another, like ADFS, for example, and you do have controls in place to block application access. So as long as this user in the left maps to the user on the right, you've blocked access. But because you've got a non-federated domain registered within your Azure tenant, that admin, if he's an admin of the tenant, or if he's in another role where you can do that, you can actually create a license and assign that user a license to email, and it's totally out of scope of this. So the Azure AD environment adds additional controls by providing another security layer within the authorization event, so it extends the OpenID Connect and OAuth processes. And this is where all the access controls, user journeys, authentication happens in that authorization event for B2C, external identity providers, and B2B trusts. And the control plane for the security is specific for each AD tenant, allowing these controls to be propagated. I'm going to talk a little bit more about that in a second. The recommendations, though, is if you are using any type of Microsoft 365 applications, then you can migrate your on-premises applications, utilize modern protocols, and use your Azure AD tenant. And if you do that, you should try to use your Azure AD authorization controls first, because it's tough to manage If you have a lot of applications and you're using the modern authentication protocols all to secure access, you know that you have a lot of scopes involved in trying to isolate users and control what users can get to. You can do it a lot easier using Azure AD and those control policies that are provided by that authorization event. Try to do that first. And then if you can't do that, then go ahead and use your application authorization. And I would not recommend to utilize federation. I know sometimes in the migration process from on-premises to the cloud, that's the first step in enabling the migration to Azure is to use ADFS. But don't think of it as something that is adding security to your environment. It's just adding another control plane. And you don't want multiple control planes. You only want a single control plane. The other thing is if you are already using a modern authentication provider for applications, then you should use Azure AD as a trusted IDP, because that way you do have those control policies in place. But in that case, things are additive. So if you do have a third-party modern authentication provider that you're using, there's still two control planes, and that control plane is the control plane where that application is registered. So I'm going to go over some logical diagrams to show in a little bit more detail how some of these things work within Azure. First of all, I've talked about the authorization server, and that's a key to where these authorization events happen. Well, there are a lot of them in Azure. And when you create an application, if you go to the application registration within Azure and try to create an application, you have a lot of choices. Well, these choices actually are different authorization servers that you'll be using when you do this. And the first four here that I have, those are in a standard AD account, an Azure AD tenant. And the last one there is only available in a B2C tenant, but now there's external identities that are available within Azure AD, and I'm going to talk about that a little bit too. But that language may change for that. When I made this slide deck up, these first four there are the ones that were available in my Azure tenant, and the last one was only available in my B2C tenant. So let's look at these. If you create an application in a single tenant, this is your authorization server endpoint. Now, of course, you do have more than just authorize. You have your token endpoint, configuration endpoint. I'm just using this as the main. This is where you get the authorization token, or get tokens when you're using, when you're not using implicit flow. When you use implicit flow, well, when you do use implicit flow, tokens come from this endpoint. Otherwise, you get it from the token endpoint. But anyway, you get what I'm saying, is that the address there is the authorization server endpoint. And it's using the tenant as the authorization event broker, meaning that any identity that is defined within your Azure AD tenant will be using this endpoint. Now, if you create a multi-tenant application, it's kind of misleading to say that it's a multi-tenant application unless you really think about what it is. Multi-tenant application means that you're registering that application across all of Azure AD. And so when a user tries to access that application, because you've created it for everybody within Azure, that application will be, then the object will be created within the user's tenant that is accessing that application. And because of that behavior, we'll see later on that how this looks, but you can't, if you have a multi-tenant application, that really means that it's only one tenant can utilize that application, only users within your tenant. I'll show that in a minute because it sounds confusing. If you create an account in an organizational directory and personal accounts, this is the endpoint that you're going to. This is the authorization server endpoint. You're going to the common endpoint. This joins those two different account environments together. And it can, so if you go here and you put an Azure AD domain in your login, then it knows to go to the other tenant to log in. If you put in an Outlook.com or Live.com or something like that, anything other than an Azure domain, it's going to go to this endpoint here, the consumer account, and try to find that domain. So this here is a combination of this one and this one. And finally, we have a B2C Tenant Authorization Server. You can see this is a little bit different because it's got a policy name in it. So when you're using this, a B2C environment uses as its authorization server an additional component of the policy. So you're forcing that those authorization events to go through the trust framework policies. And that's what gives you your user journeys. So that's why it's really customizable for your environment to get that authorization, the validation, that authorization event. You have complete control over that. That's why B2C is really powerful. So I'm going to look at some of the applications and look at some of the logical diagrams here. And I know these look really busy, but this pretty much shows you in a block diagram what's happening. So let's say you have a user, and this is a single tenant application. So that means that application is registered in your tenant. That application GUID is only in your tenant. What kind of users can access that? Well, right now you can have any local user that's defined within your tenant, or you can have any other Azure tenant user that will show up as an external user or a B2B user. You can have a federated user that will also show up as an external user. It's known as a B2B user, or any Google, Facebook now that's an external user, because now with external identities you can create trust with Google and Facebook, and I expect more will come from that eventually. So what happens here? Well, if it's a local tenant, if it's a local tenant user, it's going to go to that authorization server, and that authorization event is going to trigger a local tenant login within your environment. If it's another Azure tenant, the authorization event is going to go to the external Azure environment to verify your authentication and bring back a successful authorization event there. And then you can get your tokens. What's going to happen if it's a federated user? Well, it's going to go to your authorization server, and it's going to recognize that domain has been federated. So it says, oh, I have to go over here to this guy. So you've got the security token service mapped there. And you also have to have some type of application registered so that you can have this trust with your authorization server with your Azure tenant, and those are the federation metadata that you share with each other. And so that's what it does. The authorization event goes over here, wants you to authenticate, you authenticate, and if you authenticate successfully, it communicates back to this authorization event, and then the authorization server can then give the appropriate tokens, and the tokens that you get are the tokens from this Azure tenant that you're logging into. And what happens with the Google Facebook account? Well, again, it goes to this authorization server. It knows that you're trying to go to a Google or Facebook account, because if you go to your login screen, it says something along the lines of log in another way, and then you click on that link, and then you come up with the choices of Google and Facebook because you've configured your tenant to be able to go to either one of those two. And then once you click on one of those, it's going to go over to this different authorization server, which happens to have the old format of the Azure B2C environment where you have the login.microsoft.com/TFP/tenant ID, and so it knows to use a trust policy framework. So with that, because it's using the trust policy framework, it says, oh, I need to use whatever user flows are in my URL that I'm going to, because it's redirected to that. It goes to use the user flows that you've configured in your Azure AD environment. And this can be a sign up, sign in flow, whatever you've designed within that environment. And then you also have to create a trust with the other environment, like with Google or Facebook, because what's going to happen is that this authorization server is going to want an authorization event and go to this other environment. So you have to have an application registered over there so that you can get an authorization, successful authorization event back and get tokens back to get this verified. And once you get those tokens back and those are verified, then you get tokens back here to this authorization server, which says, okay, this is valid. I'll go back here to this authorization event and get those tokens. And finally, you get back here. And then this is how this actually offloads that identity to the other identity provider. A multi-tenant application. This is where it's kind of crazy, where you think that a multi-tenant application would be a lot more complicated, but it's not. Because when you create a multi-tenant application, you're registering that in a global common authorization server endpoint. That's where that application is being registered. So what happens if another tenant uses that application grid gets automatically registered into your environment, unless you block it, and then you have to have admin consent. But typically, or in most situations, people don't block that. I know a lot more people have been blocking that now, but there was a time when Microsoft didn't recommend blocking that. But if you don't block that, then if it's a common application, then what's going to happen is as soon as your tenant user goes to that application, it'll register the object ID in that tenant. Well, you're thinking, well, what if you have another B2B user here in this environment that represents another Azure tenant? It's he's your B2B user, you have that application ID registered in your tenant, then that would mean that he can use it, right? Well, no, he can't use it, because as soon as he would go to that application, he would authenticate to his tenant, and then that application would be registered in his tenant, not your tenant, so you don't have any control over it. And this is exactly why a multi-tenant application like Office or like other multi-tenant applications within Azure, it's only localized to local users in your tenant, because there's no way for an external user to grab that, to share that. It's only within that tenant's environment. And it's focused on only the local tenant. So let's look at a B2C application. If you look at a B2C environment here, this looks really, really similar to this environment here. And in fact, Microsoft is merging this so that eventually these two environments will be the same. But the difference between this environment, which is a single Azure tenant, and this environment is that everything here, whether you're a local user within this Azure B2B or B2C tenant, whether you're an external user that's a trusted user or a federated user or a trusted OAuth 2 OpenID Connect identity, you're always going to go through this authorization event, which utilizes the user flow. Now that's if you use a B2C endpoint. Now you do have an option within a B2C tenant to use this type of configuration where you do have a single tenant application. But if you do that, then only your local identities and trusted B2B guest identities can utilize that application. You won't be able to get to your federated users or Google, Facebook, other third parties won't be able to use that application. So those are only in special cases when you do that in your B2C environment. So here, like I said, anybody here that's going to go to a that wants to gain an application access here, the application will point to the authorization server with a specific policy in its name in the redirect there into the endpoint that it's trying to connect to. And then that policy will determine what authorization events are successful. So it's an extension of the protocol that policy is. And then the policy here can run the user journeys. You can customize it completely. You can just bring back default tokens. You don't even need to authenticate. Or you can authenticate to 12 identity providers if you want to. It's really customizable. So this just opens up the whole authorization event to anything you want it to be. And again, the same user flows here for the security token service of a federated environment and for an external IDP. The other difference is that in this environment, you can have any OAuth or OAuth to OpenID Connect provider that's an external IDP that you trust. And in this environment, you only have Google and Facebook. So in conclusion, what I wanted to show you is the integration between modern protocols and Azure AD and how that security is enhanced by Azure AD. So when you have Azure AD applications, they can either utilize the normal OAuth to OpenID Connect authorizations based on tokens, or you can also control it via the successful authorization events that you get back from your authorization server. And Azure AD environment has a lot of different authorization server endpoints. So these endpoints are determined by the type of application you're creating as well as the type of tenant that you're using. And in some situations, the authorization event, when you design it this way, is linked to other authorization servers for producing additional authorization events. And one thing to remember is that the successful authorization event is always under control of the system where the application is registered. So if you have an application that's pointed to an authorization server, that event is always under control of that system, the ultimate control of it. So if you daisy chain them out to 50 or 60, the ultimate control is always at the first one that you implement. And that's it for my presentation. Is there any questions? Let's see. No questions. Is there any other questions? Please type them in if you have questions. Okay, I guess there are no questions. Okay, thanks guys.